As John said, I'm a PhD student in neuroscience, and the main theme of my thesis is the behavioral and functional characterization of the natural motor and cognitive habits in healthy subjects and Parkinson's disease patients. As my colleague Josefa explained very well before, the brain has two major systems to control movement and behavior. One is the goal-directed system, and the other one is the habitual system. And these two systems has been linked to two different corticostriatal loops, specifically the goal-directed behavior, the goal-directed system is connected to the associative corticostriatal loop, while the habitual system is connected with the corticostriatal sensorimotor loops. And as Joseph explained too, this part of striatum is the part that is more affected in Parkinson's disease. From the early stages of the disease. So when we approach to realize this study, we realized that we have three important challenges in the study of habits in human that we have to front of. One is the need to connect the real-life habits with one studied and created artificially in the lab. The second is understand if there are any differences in how automaticity develops in motor versus cognitive tasks. And finally, very important point for our center is understand the role of motor and cognitive habitual behavior in Parkinson's disease. So the aim of this project is the evaluation of motor and cognitive natural habits to understand the differences in motor versus cognitive tasks and the influence of the early dopaminergic cell loss on habitual behavior. So to reach this aim, we have developed a behavioral protocol composed of these three parts: the neuropsychological evaluation and two computerized tasks. One to assess the cognitive component, and the other one to assess the motor component. So we have started this project, and these are the first results that we obtain. And for the neuropsychological evaluation, we can see that there are no significant differences between groups. So patients and healthy control are pretty similar in this part. For the cognitive component, so to assess a natural cognitive habit, we developed a go-no-go association task to measure an implicit automatic bias as a tendency to associate something familiar with positive concept, with positive words, and something that is unfamiliar with negative concept. We know that a bias can be defined as association between concepts in memories, and that these associations are automatically activated in presence of trigger stimulus. So we thought that a measurement of an implicit bias could be considered as a social cognitive habit. So we developed this task. It has 4 go conditions, and as the measurement of the implicit bias, we expected a tendency to respond more quickly on blocks that are congruent with bias compared with the ones that are incongruent with our bias. These are the results, and we can see that there aren't significant differences between groups, but there is a congruency significant effect, which means that independently from the Parkinson's disease group or for the healthy control group, the subject performed more quickly in the congruent block that in the incongruent ones, and the same happened for the mean of errors. They had less errors in the congruent block than in the incongruent ones. And last, we thought that a natural motor habits could be measured using handwriting. So a series of writing tests were collected from the more automatic option like signature and writing in Spanish to the more complex and goal-directed condition like writing in other languages like Polish and Greek. We recorded these variables, and specifically the last two are the more important to evaluate automatism in handwriting. And specifically, lower value of these two variables means greater level of automaticity. And these are the results of this task. For the duration, horizontal amplitude, and vertical amplitude, we can see significant differences between groups, but we can see a language effect. But when we move to the variable more connected with the automatism, we can see that there are significant differences between groups, specifically between the variables, the conditions that are more habitual, like signature and Spanish. In this case, this means that healthy patients with Parkinson's disease showed less automaticity in these variables, in these conditions. So finally, from these results, we can conclude that at neuropsychological evaluation, there is no significant difference between patient and healthy control in habitual components. In the cognitive task, we can see that in the C group, in the two groups, there are the same pattern for which subjects are faster in congruent condition than in congruent one. So there is no significant difference between patients and healthy control in the natural cognitive task. And finally, we can conclude that PD patients show less automatism in the execution of habitual condition, of habitual motor condition like signature and Spanish in our task. So a preliminary conclusion of this study is that in the comparison between patients with Parkinson's disease and healthy control, there are more differences in habitual motor behavior than in cognitive one. And this is all. Thank you.
Thanks so much, Pasqualina. That was a very interesting talk. And once again, if you have any questions, put them in the chat or Q&A. But that's a lot of work at the beginning of your PhD. And I have to say that once again, this just sounds like me talking about my talk later. In our own work in people with Parkinson's, we've had very similar results. Is that simple behavioral tasks like go, no go, we see similar response times. It is when we get them walking and doing tasks is where we start seeing divergence, where there's more stress upon the system. And we have the talk later on, but I published this earlier as well. Even with the simple go, no go task, while they're maintaining the same level of reaction time, they're recruiting a lot more of their motor cortex to compensate for that loss of automation is what you're describing there. And so that's like, it's such a simple thing to do, handwriting. It's such an elegant solution to illustrate it. I really love that. Like there's a paper recently saying, defending the that people should do behavior. Behavior is what drives forward, not electrophysiology. And I think that's a perfect example of it. You can do, like I had, for my own, I had a VR, I had to do all these things. And instead I could have just got them to write their name to see if there was a difference between automation and non-automation. It's such an elegant way to approach. But once again, kind of bring it back is, how far along are these patients in the progression of their disease?
No more than 2 years. So they are
still
really
quite
early.
Yeah.
Yeah.
But once again, they are showing symptoms, which means, as Josepha said, like that could be 12 years they've had the disease.
Totally.
And it's a very indirect measure is years since diagnosis, because you could ask, you can, and I know with the neurologists I work with, there's also years since you believe symptoms onset and things like that. And it's a very fuzzy yeah. time period, you know?
Yeah. Actually, there are some patients that have a diagnosis or 1 month or 2 months, but when we talk with them and ask for the onset of the symptoms, it could be years before. So.
Yeah, absolutely. You know, sometimes you don't notice a subtle thing. Like some people don't realize they have a tremor because it's a slow progression. you know, so it's these kind of simple tasks, and like a lot of tasks that people do or you can learn or whatever, but something like your handwriting that you do all the time, like your signature, it doesn't matter how many times you ask the person to do it, because it's meant to be automated, and that's a very difficult thing. But similarly, and once again, like with diseases like Parkinson's or the others, people misrepresent what could be a cognitive issue, but it's not a cognitive issue, it's a motor issue that's impacting cognitive response. And so it's these subtle differences that are so important. So yeah, and then as Thomas was saying, like, and we'll have that progression between onset symptoms and how to know what point it is yeah, no, well, I've thoroughly enjoyed all 3 talks for 3 very different perspectives, but actually all kind of addressing now the guy named Dan Goodman, who did the algorithm to match things, he'd be delighted to hear that this works. So maybe it's random chance. Don't tell him I said that. This isn't being recorded, is it? But things like that. So
I would have a question, John, if I might.
Yeah, of course.
Is there evidence that if you do, I don't know, motor coordination training, that you can strengthen the coping mechanism of the mental decline, or?
There is some evidence, I think, that if patients do some kind of motor training, it can help to the cognitive decline too. Yeah, I think that there is some evidence of this.
That's cool. I mean, it's a whole new argument for doing sports.
Oh no, like I always, once again, I'm a mathematician who works with neurologists, so don't take my word for it. I'm definitely not that kind of doctor, but I would argue that people like yoga and things like that, because what happens with a lot of freezing a gait, for example, or a lot of these things, is the feedback loop isn't working as well as should. And if you walk around in your shoes, you get very little feedback. And therefore, it's better to train that. And even having that motor feedback is definitely going to benefit other areas. Like the brain is super connected, you know. If you can stop the decline in one area, it's going to impact the other areas as well. Because that's like the one thing, shoes are great, but, and I'm not saying people shouldn't wear shoes, but you do lose a lot of somatosensory. So a lot of my work is self-motion perception, but you lose a huge amount of somatosensory and proprioceptive information by wearing shoes. So
I would need to talk offline later with you or John on this one, because my little son has Down syndrome and also a lack of proprioceptors. So I think that there's a very strong correlation between.
Oh yeah, and a lot of disorders have this early. Like with Parkinson's, we were showing I did some work on multi-sense integration in Parkinson's, and you know, you have this thing is that it's not the sensory system that you think is the issue; it's the other part that's the issue, and how they interact and those long distance connections. But it's same with and my work with autism, you know, sensory processing, proprioceptive, it's more prominent because you can see when someone's not feeling something. You can't see when someone's not seeing something. Sometimes it's, you know, thing. Well, we're going to have to finish so that the next session can start.